Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 30th, 2026, about 4 days ago. It introduces an agentic framework that orchestrates specialized models to produce publication-ready diagrams and plots, achieving a 17% boost in overall quality over current baselines. The paper is titled PaperBanana, Automating Academic Illustration for AI Scientists. And as we'll see shortly, the results suggest a major step forward for autonomous research systems. To start, Figure 1 showcases the sheer variety of illustrations the PaperBanana framework can produce. On the left side, under methodology diagrams, we see intricate system architectures and flowcharts, which combine icons, arrows, and text labels into coherent professional layouts. These resemble the high-quality figures often found in top-tier AI conferences. Meanwhile, the right panel displays statistical plots, demonstrating that the system also handles precise data visualizations, ranging from diverging bar charts to heat maps and pie charts. So, Figure 2 breaks down the architecture behind those results. The process begins on the far left with two inputs, the source context and the communicative intent. From there, the workflow enters the blue linear planning phase. Here, a team of agents gets to work. A retriever finds reference examples, a planner structures the content, and a stylist optimizes the description for aesthetics. Once the plan is set, it moves to the orange iterative refinement loop. In this stage, a visualizer generates the actual image, while a critic reviews it against the original facts, looping back up to 3 times to fix any errors before producing the final illustration. Well, having defined the architecture, the authors needed a solid benchmark to test it, so they created PaperBanana Bench. Figure 3 details the composition of this dataset. The donut chart on the left shows a balanced mix of 4 research domains, with agent and reasoning taking the largest share at roughly 32%. Meanwhile, the bar chart on the right tracks the aspect ratios. The authors filtered for ratios between 1.5 and 2.5 to match realistic landscape figures, with the majority falling in the wider bracket. Okay, moving to the actual performance. Table 1 compares the framework against several baselines. The upper section shows vanilla settings, where direct prompting struggles. GPT Image 1.5, for example, manages an overall score of just 11.5. PaperBanana Pro does better alone, reaching about 43, but the real gains appear in the agentic framework section below. Here, the full PaperBanana system, driven by PaperBanana Pro, secures the top overall score of 60.2. Crucially, this surpasses the human baseline of 50 at the bottom, meaning the automated diagrams were frequently judged as superior to the original human-made figures. So, having established the top-level performance, Table 2 now dissects the system via an ablation study to see exactly which components drive those gains. The first, shaded row, represents the full PaperBanana framework, which uses 3 rounds of critique to hit that peak overall score of 60.2. Looking at rows 2 and 3, we see the impact of the critic agent. Dropping it entirely in row 3 crashes the score to 45.6, proving that iterative feedback is essential. Then, comparing rows 3 and 4 reveals an interesting trade-off with the stylist agent. While the stylist boosts aesthetics, it actually lowers faithfulness significantly, likely because it simplifies technical details to make the image look better. Finally, the bottom rows confirm that removing the retrieval step entirely yields the lowest performance of all. Alright, moving from the numbers to the visuals, Figure 7 presents a side-by-side case study comparing the methods directly. The top row displays the original human-made reference diagrams for 2 different cases. Below that, the middle row shows the output from the vanilla PaperBanana Pro model, which tends to be cluttered and relies on outdated monochromatic color schemes. In contrast, the PaperBanana results in the third row are much cleaner. They use distinct modern color blocks like soft blue and orange to group functional modules logically, which significantly improves readability. Wrapping up, 2 takeaways stand out. First, PaperBanana effectively automates the complex task of scientific illustration by coordinating specialized agents for planning, styling, and critique. Second, by surpassing human baselines in aesthetics and readability, it removes a major bottleneck for autonomous AI scientists, enabling them to communicate findings visually as well as textually. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.